Hi everyone, can listen or not? Hi. Can Lena, Lena, can you on your mic? Can you on your mic to answer me? I want to see my.
Yes, teacher.
Okay. So you all take out the exercise 3.1 because some students got pass up, some never pass up. So I want to give the answer lah. Okay. So I turn my screen. Okay. Can see or not? Okay, you take out this one question. Okay, how many here already finished? They already pass up to me, but some is not yet pass up. So you want me to show you how to do, or you straightforward give me the answer for the student not yet pass up, but you are finished. Pass up one, I mark already, then I return back. Some are not yet marked. So from here, anybody can tell me the answer? I Lena Pay, you got do or not? Okay, some students still want to enter in. Okay, so Yiru, have you finished the paper? The first question, they got a example, the big example day.
Yes, sir.
Can you give me the first answer?
7.60 times 10 to the power of 6 second.
Yes, okay, I show you the calculation for the student. You are not yet do it. Then I show you the calculation. Okay, this one. You all can see my screen or not?
Now, teacher.
Can see or not? Yiru, can you see my screen?
Nothing.
My screen is nothing.
Ah,
Okay, wait. My screen is nothing. Okay. So I show back. Okay, now can see or not? Can see or not? The others can see my screen or not?
Yes.
Okay, can see the example question 1, is it?
Yes.
Okay, so this one is the answer lah. The same as your answer just now you mentioned it was 7 point. Okay, if you give more decimal point, it's more accurate lah. But normally we give 2 decimal point for this one because 9. So after that we take 7.60 lah times 10 power of 6 then second. Okay, I think this one no problem, is it? We just apply the equation, the last equation we learned. Okay, then they want to find the mass. Okay, so they want to find the period. So from here we apply this formula that got period. We just got one formula that got period. Another one is a 2 pi r over t. The problem here, we do know what is a velocity. Okay, so from here we need to find out using this formula. After that we get the answer. Okay, the rest, if you cannot see clear because I got record already. So later I also will share here. Okay, now we go to second question. Okay, anybody here can answer me second question? Okay, automatic to on your mic. I don't do one by one, go and see who is that. Ishan,
Yes, teacher.
you give me your answer for the question number 2.
4.95 times 10 power of 11.
Number 2, or they want the period of the revolution, or 4 point something, you find it.
4.95
4.95. Okay, now we go and see the answer. Actually, is what?
time.
Okay, we check first. Okay, this one is the number 2. Okay, this one. You see the answer is 1.08. Have you go to square root? Not square root. You need to cube back. Got or not? Because this one period of the revolution, okay, given. Okay, after that, they ask you to find is a radius of the Venus. Okay, after that, we apply the formula for this one because m we know already. Okay, after that 4 pi square, then r cube, then gt square. Okay, make sure the formula you are correct. Then after that, we know the mass. There's a 1.99 times 10 power of 30. Okay, 4 pi square r cube. Because we do know the r cube, so we put r cube first. Then the g constant number already. Then the period already given. Okay, 1.93 times 10 power of 7. So remember your t got square. Don't forget the t got square. Okay, after that, we bring the r cube go another side. Okay, then 1.99 we bring down, divide. So you can try to do. Okay, the others, have you get this one answer? I want to ask the one who Aho, your answer is it this one? 1.08 times 10, 11?
No.
Your answer is
4.99 times 10 to the power of 7.
4.99.
Yeah. Because
Okay.
wrong, the power is wrong.
Yeah, your power is wrong. So the others, anybody here? JS Tan? Hey, Aho, you help me to apply again. You use your power is correct one.
Yeah, the correct one get 1.07 times 10 to the power of 11.
Yeah, almost like this. Because I get 1.075. Okay, so this one is the exactly number. 1.075 times 10 power of 11 meter. Okay, the others, anybody here? I don't see anybody here. Esther here or not?
Yes.
Esther, can you do the calculation?
Yes.
Yes, Leonard, today too early already. Have you do it?
No, yet, teacher.
Mei
Do already.
do already. The answer correct or not?
Wrong.
Wrong. So I think you are pressed wrong, or you are apply the wrong formula.
No, I don't know the the T number of
You don't know the
T.
T because just now the T you wrong already.
The T I put wrong number.
Okay, so that means you need to take out the T just now lah. You do the calculation for the T, then you bring in. So make sure the T should be correct lah. Then after that you can do the calculation. If not, also wrong.
Okay.
Okay, so this topic because the number too big already. So make sure you all do the calculation. You press two or twice or 3 times to press. Is it the answer? Make sure there's a correct. Okay, because sometimes we press calculator, we straightforward to press. Then square already, after that you go to divide some more. Maybe the calculator, they miss. They don't know which one to do first. So better every time you do calculation, you equal already, you copy the number. You copy the number, after that you do another calculation. And then you copy again. After that, what you copy, you just go to divide. You check, is it correct or not? So this one is another way lah. Unless you got 2 calculator lah. You got 2 calculator, that means you can press it. Okay, so this one is a second question answer. Okay, so now I want to go to the question number 3 lah, that one from your textbook one. Okay, I think the student also can do it. They pass up one, normally is a correct one. Some they miss out is because of the number. That's the power. The power they put the wrong number. Okay, now I want to open is question number 3. Okay, this one is number 3. Okay, a piece of the space junk of a mass 24 kg. Okay, this one 24 kg. Okay, now the distance, they give you the distance already. So understood this one is a R lah. Okay, this one is a R. Okay, from the center of the earth. Okay, what is the gravitational force? So they want to find the F. Okay, we know the mass, first mass, another one is a mass of the earth. Then the G, you can press your calculator straightforward, you get the answer. Okay, G is how many? You no need to press 6.67, you know, you press the one CONST, after that 39. Then you know this one already. Then after that, you multiply with 24, multiply with the mass of the earth, then you divide, remember square. And also remember put bracket. Okay, you put the bracket. So after that, normally, at least we give 2 decimal point. Okay, if 50, then you no need to put 50 or 19.5. You got 51, then 19.51 Newton. Okay, so this one is question number 3. I think everybody also can be answer this one because this one just straightforward apply the gravitational formula. Okay, now I want to move to the question number 4. Okay, let's see question number 4. Okay, question number 4, a little bit thing you want to add because they said the satellite. Okay, when the question just talking about satellite, you must be careful because satellite, they can move. They're not just on the surface, they can move. So from here, they say the satellite, they orbit the earth at the height. This one is many students, they pass up, they never realize they got kilometer times 10 power of 3. Okay, what is the value of a gravitational acceleration at the position of the satellite? They want to find G, gravitational acceleration. They never say gravitational force. They want gravitational acceleration. So this one is far away from the surface. So we must think about the formula. G equal Gm. Okay, remember at the bottom we got R plus H. Then after that square. So this one is a formula for the question far away. So this type of the question, what you need to do first, you find this one first. Find the distance. Because this one we cannot straightforward press the calculator. Divide. We need to find out this one total how many first. After you find how many, then you put in. Like this, you can straightforward do the calculation. You press the G, multiply with the M. After that, you straightforward divide. Then you put a bracket. 6.93 times 10 power of 6 bracket back. Then you put square. Then this one equal. Then you can get the exactly answer. Okay, you cannot say, oh, I do the up first, then down. After that, I go to plus, then the square, I divide. No. Like this, your calculator misunderstand what you want to do. So we do the plus first. After that, we write out what's the answer. Then continue, we do the calculation. Okay, so finally, I find the G is 8.292 ms negative 2. Okay, so when I just talking, nobody want to stop me, means you are okay lah, is it? So you don't understand, better you go to ask. Because when the school just reopen, memang is finish this one topic, you know. Okay, nobody want to answer. Nobody want to ask. Yes.
Just now the question 3, right? My
Yes.
answer is 195 Newton, but your one is 19.5, I think.
You are 195. The others, can you get sorry, I think my answer got a little bit problem. Okay, the others, I marked your answer already. Can you give me what's your answer? Hello, the others, pass to me already. Then I mark already.
1.95.
I give you 1.95 times 10 power of 2. Yes or not?
Yeah.
04.
Okay, so I do the correction. Okay, I show back. Okay, I open back the question number 3. Okay, this one calculation got problem. Okay, at the top is okay, is it? Just the answer wrong, is it?
Yeah.
Okay, so we write here, this one is okay. So this one got problem. Okay, the problem should be 1.95 times 10 power of 2 Newton. So that means you can write 195 lah. Okay, correct or not?
Yeah, yeah.
Okay. Okay, number 4, any problem or not? Got any wrong or not? Number 4. Just now I show you number 4. 8.292 ms -2. Correct, yeah? I think this one is correct. Okay, then we go to number 5. Number 5. Okay, this one is number 5. Okay, number 5, they say satellite again. Satellite, if the mass is 400 kg. Okay, they give you the mass of the satellite, 400 kg. Okay, also orbit the Earth. That means we got 2 body now. One is a satellite, another one is a Earth with the radius. Earth radius, this one is. Okay, linear speed of the satellite 6.96. Okay, what's centripetal force? Okay, they want to find FC. So FC, the formula, okay, m v square over r. Okay, before that we take F equal ma, is it? So the m from here they never say the pi, never say talking about the period, so we cannot using another formula. We just can using this one because they provide is a velocity. Okay, so we straightforward apply there's a velocity. So just put in a 400 kg. Then after that the velocity is a 6.96 times 10 power of 3. Okay, remember v must square. Okay, and divide by the r. R is no square. Okay, r is no square. Okay, a equal v square over r. So actually this one a. Okay, so from here we just apply. So we get it, the answer is 2363 Newton. Or you want to write standard form is okay. 2.363 times 10 power of 3 Newton. Okay, this one is a centripetal force that's related with the velocity. Okay, then no problem. Then we go number 6. Number 6. Okay, this one's a number 6. They got diagram. A Mercury that orbit the sun with the radius. Okay, with the radius from the center of the Mercury to the center of the sun. Okay, make a period. Okay, they give you the period. So you understood lah. Understood when they say period. So which one formula you want to use? Sure got 2 pi r v square, 2 pi r square over the t. So from here, calculate the mass of the sun. Okay, so we take out the formula. Mass of the sun. So this one is the sun one, not Mercury. Normally they want to find out sure is a biggest. The body there's a bigger mass they want to find. If they say mass and Earth, they should be find about the mass. Okay, so until here we also do know what is the mass of the Mercury. Okay, so they want to find about the mass of the sun, so we just apply this formula. So the formula is very important. If you miss out square or cube, that means the following, then you are wrong already. Okay, so important is this one because they got cube, after got square some more. Then bottom, the t also need to square. Okay, so from here you can apply the formula. I think this one hilang already, is it? Half hilang already. Okay, suppose it's 4 pi 10 power of 10. Then after the cube. Okay, then this one is a 7 times 10 power of 6. Then square. Okay, so 4 pi square. Then the radius, you put the radius in. 5.79 times 10 power of 10. Then cube. then G, after that the T, the period, then you go to square. So the final answer is 2 times 10 power of 30 kilogram. Okay, so this one is the last question for the last week exercise, the last lesson exercise. So we want to continue is the following one. Okay, so any question before I go to tutorial? No, no, then I want to move to the tutorial question. Okay, tutorial. Okay, I open this one first. Okay, this tutorial, they give you all the formula already. So we open the first one. Okay, let's see the tutorial. Okay, they give you the info already. They give you the mass of the sun, all the thing, mass of the earth, radius, then G constant, mass of the moon and radius of the moon. Okay, this one is a fixed number. Okay, after that we give you the formula also. Okay, well, gravitational force. After that, gravitational acceleration, centripetal force, mass. Okay, so from here, I think one more thing I forget to tell you. Got one more formula here. Okay, you can see here. Okay, I add some more formula here. Just now is 1, 2, 3, 4. Okay, this one, Kepler third law, no need to see first. Okay, actually this one how to come? Okay, this one how to come? This formula how to create? Anybody can tell me this one formula before that what we learned? Okay, remember we go to create this one. Centripetal force equal to the Newton gravitational force. So centripetal force, there's a mv square over the r. Then this one is the first one what we learned. There's a g small m over r square. This one is the first one what we learned. Then after that we go to cancel the small body. Okay, finally we get it. The capital M equal to the v squared r over g. This one formula is last time we learned one. Then after that we go to take out the v, we become 2 pi r z. Okay, so from here, some question that we find the velocity. Okay, when they want to find the velocity, so your v square must be taken out. G m over r. Okay, v equal square root gm over r. Okay, just like this only. Okay, this one escape velocity we still not yet learn. So this formula they just create from this part. In your notes, there's a page number 10. They calculate the mass of the sun and also the earth. Okay, so from here, you just learn until the mass of the earth, that's enough already. So this all thing, we don't need to see all. Okay, now I go to start question number 1. Okay, question number 1. Okay, let's see number 1. Calculate the gravitational force between the sun and also the earth, where the distance between the center of the sun is, okay, this one is R. Okay, they want to count F. So everything we can apply lah. Okay, F equal G, then the mass of the sun and also the earth, because two objects, capital M, small m. Okay, after that, distance R square. Okay, I want to know answer. Anybody here can straightforward give me the answer? Or do or not? Some just on after they go to sleep already. No response one. 20% here. 19% here. Eric Chu.
Yeah, teacher.
Yes. Finish. Give me here, teacher. They finish.
I will do.
I won't do. So can you do now? Yes, done. Yes, crash. Yeah, Jess done. You want to give me answer?
3.54 times 10 power of 22.
Yeah. Okay, that one is the answer. That means I show you the formula already. Then you need to press, it's your problem for press the calculator. So the answer I just write here. So you can check. If you're wrong, so you copy the answer first. Then after that, you go to press again your calculator. Times 10 power of 22 Newton. Okay, this one is the answer. Okay, the following. Okay, now they got 2% with the mass 80. That means one person 80, another person also 80. Okay, respectively stand with the distance 50. Okay, this one 50. Okay, after that, calculate the gravitational force between them. That means you have got gravitational to another one also got gravitational pull for you. Okay, then we answer the first one first. We do the calculation first, compare later. Okay, calculation also same. They want gravitational force. So they want F lah. Okay, G, 2 also 80. So you put the mass both also 80. Okay, distance between is 50 cm. 50 please convert to meter. Times 10 power negative 2. Okay, then after that you need to square. Okay, can get the answer? Today Nixon not here. Gone up. Not here. Okay, final answer is
1.71 times 10 power of negative 6.
okay, correct. So this one should be the answer. Okay, now we continue to compare. Compare the value of the gravitational force with their weight. Okay, you are here. So your weight is go downwards. This one force is go here. Your friend acting to you, you acting to your friend. So these two force is a different thing. So now we go to explain this one. How to compare. Okay, the answer is which one bigger, you tell me. This one, gravitational force bigger or your weight become bigger? Okay, if you count our Earth, the gravity is 9.81. So you how to count your weight? Your weight is W equal mg. So you must take 80 multiply with 9.81. This one number already big enough compared to this one. This one got negative 6. Sure, our weight is bigger than this one force, yes or no? That's why you can stand. If this one gravitational force bigger, that means you pull by your friend already. You two together crash together already. You cannot stand there. You are flying. Okay, so from here your answer is the weight. Okay, their weight greater than the gravitational force between each other. Then we just compare only. So sure that one is a bigger. Okay, remember these two force is a different. One the force is okay. This one 9.81 actually is what? 9.81 is the force between you and also Earth. Okay, this one force, gravitational force between you and your friend. Okay, two forces is a different. So we do the comparison. Sure, the force you acting to the Earth, that one sure is a bigger. Okay, their weight. Okay, so this one is the answer for number 2. Okay, then we go to the number 3. Okay, number 3. Okay, the spacecraft. Okay, Columbus has a mass. Okay, first one they tell you the mass. Okay. Okay, is launched from the Earth to the moon. From Earth to the moon. Okay, calculate the gravitational force between spacecraft and also the Earth. Okay, never ask about the moon, just about the spacecraft and also the Earth. So when the distance between the spacecraft and also from the center of the Earth. Okay, so you save already. They never say surface, they say center already. So you no need to plus anything. Okay, no need to plus the radius. So from here, they still want to find gravitational force. They still want to find F. So we just write F mass of Jeevers, mass of the Earth, mass of the space. Okay, then over distance. Distance is 1.2 times 10 power of 9, then square. Okay, so we need to find this answer lah. Okay, can you get the answer? Okay, the answer is what's your answer? Answer is nobody can answer.
8.34 dear.
Yeah, 8.34. Then this one's a force on Newton. Okay, so this one topic, the problem is you don't understand. You understand. You also know which one formula you want to use. The problem is you press wrong. Sometimes we press already too large number because so many things you want to press, then you confuse. Then you sometimes you press already, but you forget you got press on, don't press like this only. So easier because every time you press wrong, we write first. Write what you get the first answer, follow, then divide. We write out all the things first. Okay, then we go number 4. Number 4 don't have any number here. They just say what is the height. Okay, what is the height from the surface of the Earth if the value of the gravitational force is 1/3 from the surface of the Earth. Means the thing must be far away lah, because your gravitational force become drop already. So before that, we must know the Earth gravitational force is how many? So if you do the calculation, F for the Earth lah, G, then M, N. After that, we are square. Suppose we get how many? 9.81 from the surface. This one is a standard. So from here, they say now the gravitational force you are 1/3 from the 9.81. But now I need to know what is the height they come out from the surface. So that means later you find the answer, you need to minus the radius of the Earth. Then we know what is the height. So now the formula suppose like this. F equal GM. Sorry, not F. I give the wrong thing. This is a formula for the gravitational force. Okay, if 9.81 is not there are ms -2, is it? So this one is wrong thing. So I do the correct one. Okay, suppose it's what formula? G equal for the surface formula, G equal GM G capital M over R square. So this one is on the surface, 9.81 ms -2. F is wrong because F is a force. Okay, so we go to cancel the F. Now we need to apply is a G. Okay, what is the height of the Earth if value of the gravitational force? Okay, gravitational force. I think they give the wrong thing, not gravitational force. Okay, sorry, there's a not gravitational force. There's a acceleration. Gravitational acceleration from the surface. Okay. Okay, so I explain again this question. Okay, we know already gravitational force, sure they will drop 1/3 from our Earth if they're far away. So from here, we need to know gravity for the Earth is 9.81. Okay, if your gravitational force drop until 1/3 from this one, our gravity, then we need to know now what is your new gravity if your force drop until 1/3. So from here, we do the calculation for the force first. Okay, now your gravitational force 1/3 from the surface. So that means we know your gravity is new gravity. There's a 1/3 multiply 9.81. So that means now your gravity is 3.27 ms -2. This one is your new gravity. For this one situation, normally it's a satellite because they are far away from the surface of the Earth. So remember the formula for the third level, G, M. Okay, there's a R plus H squared. So it this formula for the third part. Okay, so from here we know they are far away 1/3 from the surface of the Earth. So we need to apply this formula. So before I want to apply this formula, okay, I write this one first. 3.27 equal G capital M radius then plus H squared. Okay, what I want to find? I want to find H. So you want to find H, all the thing you just put in. So all the thing you put in. So from here, the R plus H square, I put here. Then should be GM over 3.27. Okay, now if I want to take out the square root, I want to take out this one. Okay, now square I want to take out. So what I need to do? I need to square root. Okay, after that, I want to find, okay, never mind, we find this one first. Finally, baru we go to minus. So I want you to apply this whole thing to do the calculation. Okay, my 3.27 sudah over here already. Okay, like this only. Okay, R plus H equal to this whole thing. Then you find me what is the R plus H first. Then after that, we baru go to minus the R. Okay, I want to know R plus H. So if you are on the way you are do now, you give me the answer. Okay, some will miss out this one. M, siapa punya M? Who's M? The mass is for the earth. The whole thing they're talking about the earth. Okay, R plus H. How many?
1.11 correct.
1.11
11 times 10 power of 7.
power of 7. Yeah. Okay, so now that means I can find the H. You take 1.11 times 10 power of 7. Then go to minus the radius. Radius of the earth. Okay, fine. Oh boy.
7 to the power of
Power
10,
of
6.
6. Okay, unit. What unit want to use for H?
Kilometer. Meter.
Meter. Okay, so this one is a SI unit. Okay, so this one question, they got changed a little bit. They just want to find the distance. Okay, I think this one got problem, not gravitational force. There's a gravitational acceleration. Okay, gravitational acceleration. Gravitational acceleration and gravitational force is a different. Gravitational acceleration actually is a gravity. Gravitational force is same like the force pulling. The weight, the unit is Newton. Gravitational acceleration, the unit is a ms negative 2. Okay, different thing. Okay, so this one is a question number 4. Any problem? Question number 4. Okay, no. Then we go number 5. Okay, number 5. Okay, the communication satellite again. The mass is 80 kilogram. Okay, then the orbit the Earth. Okay, orbit the Earth some more. So from here we got two things. One is satellite, another one is your Earth. Okay, the height given from the surface of the Earth. Okay, now calculate the gravitational acceleration of the object. Okay, this one again, satellite far away. So remember, now they want to find acceleration, gravitational acceleration. So there's a G. Third equation, Gm R plus H. Okay, this one M normally is the biggest one. That's the Earth, not the satellite. Because this one formula we proved already. The small satellite, we using another formula we cut already. We don't have both M for the gravitational acceleration. We just got one M only. Okay, because we're using the formula just now, the what formula is it? We're using the formula to cut it. Okay, the formula is okay, we're using the F equal mg, then the mg and the I show here F equal to mg. Another one is the F equal to the fc, not fc, the F normal F, the Newton one. That's g square. That's why this one m and this one m we cut already. Okay, we don't have the small m. We still have the capital M. So the capital M is the object more heavier. That's the Earth. Okay, what is the G? I get it. Answer for G. Who is here? 侯知慧。侯知慧 cannot answer. I call this one Lena Pay. Is it Lena Pay go away already? Play game again.
No, teacher.
No, so slow to answer me. Must be fast what if you're on the paper.
I don't know what to do, teacher.
Okay, you give me the answer. You give me an answer. Question number 5. You see? Cannot prove. Okay, what's the answer for number 5?
5.09 times 10 power of 7.
5.09. Got others or not? The answer not exactly. Others beside 5.09?
6.46.
Yes, 6.46. Okay, I show you the 6.46. So I think the problem you press calculator again. When you press again, I think you can get the answer. The problem is a calculator. Okay, I open. This is question number 5. Okay, 6.46. So again, this all thing, you do the bottom first. Okay, you do this part, the bottom part you do first. Okay, after that, you don't need to square. You want to square, it's up to you. You plus first, then you take out what's the answer first. Okay, this all thing you can straightforward press your calculator. After that, you just divide. Okay, then you tap what you find just now. Then you go to square. Then you can get the answer. Okay, 6.46 ms negative 2. Okay, then we go to the question number 6 ready. Okay, number 6, just call you to draw. Plot a graph, show the variation of the G with the R from the center of the Earth to infinity. So this one, this topic we just got one graph only, what you learned before. I also call you to using graph paper to plot it. Okay, but you need to label. After plot, please label. So I show you the answer here. Okay, this one. Okay, you plot already the line. Then you label this one. Label the which part is smaller than the R. You label this part. This part is smaller than the R. This one is exactly 9.81. So that means the formula like this. GM over R square. Okay, or you're using small r. Okay, this part is the inversely proportional. So G is inversely proportional 1 over R square. So you just show this one graph. Okay, and also the bottom, this one line cannot touching to the horizontal because they cannot actually become 0, 1. They just less, but cannot touch the 0. Okay, so this one graph, I think no problem. You also plot before. Okay, question 7, I want to do some correction. Okay, they say calculate the gravitational acceleration G on the surface of the, okay, not Earth. That is a moon. Gravitational acceleration G on the moon, on the surface of the moon. Okay, I show the question again. Okay, this one. So small one. Okay, let's see the question. Okay, number 7. Calculate the gravitational acceleration G on the Earth, is it? Okay, the question suppose is on the moon. Yeah, check first. Calculation on the moon. Okay, if we do the calculation on the surface of the Earth, means we no need to do calculation already. You also know the answer is 9.81, is it? So from here, I want to change this one become moon. Okay, so if I change become the moon, how to do this question? Calculate the gravitational acceleration on the surface of the moon. So we're still using the same formula. Before that, you calculate for the Earth is how many? They're using the G. Then after that, the G, capital G. After the M, then over the R square, is it? Okay, this one is for the Earth. Now I say moon. So you just changes this one R, this one M, become the moon mass. You change become the moon mass. After that, the R is the radius of the moon. Okay, radius of the moon, you can refer the first page. First page got any information is there. Okay, I just want to change to the moon only. I don't want the Earth. So you show for me what is your answer. Okay, show to me what is the answer. Okay, Teddy. I want the moon.
1.62.
Okay, 1.62. Then the unit should be?
ms negative 2.
Okay, good. Okay, ms negative 2. 1.62. So, why I want to change the question? Because everybody know it. You don't need to do a calculation. You also know 9.81. So I want to change the question. Okay, now we continue call question number 8. Okay, number 8. Gravitational acceleration on the Earth's surface. Okay, now they say G on the surface is 10. Okay, if the mass of the Earth is capital M, okay, and the radius of the Earth is R, calculate the gravitational acceleration of the point S distant 3R above the surface. Okay, above the surface, then you know lah. Okay, so distant above the surface, so normally we how to do the calculation? Okay, they want to find G, so it's the same thing. 3R, before that is a G, normal surface, GM R. This one is on the surface. This one is Earth, you are on the surface. Okay, now you are 3R. This one is R. This one is R. I mean now you are 3R. You are here. 3R. Okay, they ask you what is the G now. So from here, G prime equal GM. Forget this one was square. So you are 3R square. The gravitational acceleration at the point S distant of 3R. Okay, so from here, 3R above the surface. Sorry, 3R above the surface. Okay, 3R above the surface, suppose how many R? Hi, 3R above the surface. Suppose it's 4R, yes or no? I don't take 3R already. I said 3R above. So we take 4R. Okay, this one is R. This one becomes 4R. Then you plus another R. So this one is a R. This one is a 4R. 3R above the side, above the surface. So that means here become 4R. Okay, so can do calculation or not? One gravitational acceleration G normal is 10. So from here, I create the equation. G prime actually is a 1/16. G. Agree? So I want to find your new gravitational acceleration. That is how many? Gravitational acceleration at the point S. So the answer is?
Is it 0.62?
Okay. Suppose it's a 0.0625. Then the unit is ms. Okay, so this question sometimes they want to catch, you see, the point S distant 3R above. So sometimes we just, a 3R, then we just count 3R. So the questions, so they want to trick you. So you see, be careful, gravitational acceleration at the point S, the distance of 3R above. So total should be 4R. Okay, so the answer is 0.625 ms negative 2. Okay, then we go to the last question. Okay, let's see the last one. Okay, the last one, a satellite has a mass. Okay, they tell you the satellite mass. Okay, 600 kg orbit the Earth at the height. Okay, got height, because you are far away. The height is 300 kilometer from the Earth's surface. Calculate the speed of the satellite orbit the Earth. Speed of the satellite. So we got the formula, got speed. There is a just now I show you m v square r g. Okay, so depend which one mass you want to find. Now they're talking about the Earth, so this one mass sure is a Earth mass. Okay, this one v, the satellite velocity. Okay, then this one r, and this one g. Now they want to find is the speed. So that's why I want to take out the v. So v square will become mg over r. Okay, so you find the answer first. V square is how many first? Then after that you square root. So final answer I want like this. And remember, the r is how many? Okay, I want to know the r now. Okay, the r, please you count for me first. The r now is a 2. Two things you need to plus. One is the distance of height 300, and one more is a radius of the Earth. So that means now your r will become radius Earth plus 300 kilometer. Okay, remember this one question no square. This one they find velocity no square, not find the force. So final answer no need to square one. Straightforward. This one divide this one plus this one. Okay, so I want the answer is B. Okay, you can start now to do your calculation. Then you finish. You just give me the answer. What is the answer for B? Okay, can finish. The V is how many? Nobody can do. after you just press, you just give me the answer because we don't have any say, oh, you are wrong already, then you are worse. No, we never say like this one because you best you are try already. Okay, maybe some mistake only.
Teacher, is it 10 to the power of negative 11?
No. Okay, we count one by one. Okay, you all give me the answer for R first. That means after you do the plus radius and also the height, you plus already, you tell me the R suppose is how many. And we check one by one. Okay, the R, after I take the radius of the earth plus the distance far away, there's a 300 kilo. Kilo must be power of 3. Okay, you must get the answer is 6.67 times 10 power of 6. Okay, this one you get power of 6. This one is a R.
Got.
Got. Okay, then we check about mg also. M multiply with the g, you get the answer is a 4.0038, or you say 4 times 10 times 10 power of 14. Get it? If we take these two is correct, so we just take V equal this whole thing. V8 times 10 power of 14. Then you go to over 6.67 times 10 power of 6. Then you go to square root. Okay, you get the answer.
7.74 10 to the power of 3.
Yes, power of 3 and S value 1. Okay, this one is how we find the velocity, the speed. Can get or not? The others? The others got problem. We do slowly. We count one by one. Can? The others? Okay. Respond please. The other okay? Okay, that means I can
Yes.
continue. I continue the last one. Okay. The last one they want to find is the orbit period. They want to find the time. Okay, we got two ways to find the time. You can using the Ori one. Remember the very long one I show here. The longest one is the M. After that, we got 4 pi square R cube. Then over the G, then T square. You can using this formula to find what's the T. Why I want to using this formula is, can you see this formula? We don't have any V. Just now we find the V, is it? I don't want to apply the V. Why? If my V wrong already, my T also wrong, you know. Okay, or you confident your V memang correct. Okay, your V memang correct, then no problem lah. You're using V equal 2 pi R.
Huh?
over the t. Then you can get the t. Okay, if both also okay, no problem. Your answer should be the same one. Okay, now the question they want to find period. So you find for me what is the t. So this one m memang is a earth mass. Then 4 pi square. Then the r. The r is just now the r lah. Okay, just now you plus already, is it? Now you need to cube. Then you divide, then you find this one. So this one is memang the method is wrong. You press your calculator salah, then habis. So just now we confirm the V is correct, is it? So you just apply this formula. T you bring out, V put down. Then you find what is a T. Okay, you also can try this one. Later you try yourself, you try this one. Okay, now I want the answer is T. What is the period? So, that or not? Just apply the short one lah. Because the V we find it just now is correct. So your T, two pi. So R just now is 6.67 times 10 power 6 over the V. V just now is 7.74 times 10 power 6. Okay, T is
5.404.
5.404 times 10 power of
3.
3. Okay, so this one is a period. Okay, 5.509 something lah. So important we got 5.4. The behind I don't know the number lah. So almost like this. Because sometimes you do the calculation, the miss the behind, there's no point, then you get the different answer. That's okay.
我已经刷过了。
Okay?
Not
So
sure
the others?
the answer.
Not sure the answer.
Why not the radius or why not is the R plus H? Because it's
We plus already Just now you forget man, we do the calculation just now. Hilang already. Okay, we do the calculation just now. 6.67 times 10 power 6. We get already just now. There's a radius plus 300 kilometer.
okay.
We just bring in only. We don't need do already. The R. Okay. The others, are you okay? Hey, the others, nothing to say. So I just open the last question because so many things plus together. So this is the last one. Okay, so they show like this. Okay, so this one is the answer for the last question. So the others got anything want to ask? All disappear already. Anything to ask?
Teacher, number 8, how to do?
Okay, I'll show you number 8. Okay, number 8. Okay, number 8 here. Okay, you see number 8. Okay. Oh, sorry, this one my answer wrong already because just now I just read 3R above the surface. So this one must be 4R. Can you change this one become 4R? Okay, now this one answer wrong. So I redo for you. So I just open the new one. Okay, we see number 8 how to do. For the question, for the student, you will understand already. That means you can leave lah. Because the question finished already. The coming soon, I will go to 3.2. I will upload the new notes. Go there. Then after that, you go to Google Classroom. You go to download lah. So the class should be finished. I just want to repeat number 8 only. Okay, thank you. The others, Okay, number 8. Okay, they say the normal. This one is the Earth, is it? So this one is the center of the Earth. Okay, this one is the radius of the Earth. There's a R. Okay, now they say this one gravitational for the Earth G. There's a 10. MS -2. Suppose this one G, how to get it? There's a G, capital M, over R squared. This one is a surface formula. Okay, now they say calculate the gravitational acceleration at the point S. Okay, distance 3R above the surface. Okay, that means S. The S is 3R. Okay, now they want to find what is the G at the S. So we just take G gravitational acceleration at the S lah. Point S is how many? So suppose is G capital M. Now your new radius is how many? Because we take 3R plus R, is it? Yeah, after that go to square lah. So suppose is G M over 4R then square. Okay, so from here, I want to take out the G. How I take out the G? I take out this one to come out from this formula. So I equal again. So I take out 1 over 16 because this one square go in. 1 over 16. Then G and M still the same. Then this one 2 put in. Then become R squared. Okay, can you see this one and this one should be the same? Okay, mean this one is a 10? Agree? That's a 10. So now gravitational at the S is how many? 1 over 16 multiplied with the 10. So that's your answer. Okay or not? Hello? Okay or not?
Okay.
Okay, I understand. So the final answer is 0.625, I think. I think so. Is it?
Yes.
Okay. So the others got anything some more? No, the others no, that means we can quit already. So this one is the 3.1 we finished already. So the coming soon should be the 3.2 lah. I will upload again the notes. So tomorrow I will give you the exercise. Either Google form, either is a structured question. So I will upload in the Google Google Classroom. So many of you are still not yet pass up the homework. Please pass up soon. Okay, and also make sure you are upload in the Google Classroom. You just turn in. Okay, many they don't know how to turn in. So if you never turn in, that means you don't have any proof you are pass up the homework. Okay, so we are finished our lesson already. So thank you for your coming the lesson. Okay, thank you for your class and thank you for your time. Waste your time to follow the lesson. Okay, the others. So we just off lah.
Okay, thank you, teacher.
Okay, bye.
Thank you, teacher.
Thank you,
Okay, bye.
teacher.
Thank you, teacher.